Hello everyone. This is a group presentation for AI. Which is our topic is basically about what is Bayes theorem and its application. In a group, there is Aurangzeb, Shrijan, Vyom, and myself. So basically, I will start with Bayes theorem. Bayes theorem is a mathematical formula used to update the probability of hypothesis based on new evidence. It helps us revise previous beliefs when fresh data is introduced. It is named after Thomas Bayes, who laid the foundation for this logic-based approach to probability. It answers questions like how likely is something to be true, not that I have observed new information. It is a key tool for making decisions in uncertain or dynamic environment. It plays a vital role for making decisions in several real-world problems. Um, it is also helpful in very real world applications such as medical diagnosis, machine learning and AI, spam filters, and finance. Se- Next slide. Why is Bayes theorem important? In real life situations, we often don't have complete information to make perfect decisions. Bayes theorems provides a logical and mathematical way to refine our predictions when new data becomes available. It allows us to combine what we already know, which is prior knowledge, with newly observed evidences. This results in a more accurate and updated beliefs known as the posterior probability. Helps us to avoid false assumptions by factoring in how likely the new evidence is depending on the situations. It makes a decision making process more flexible, data driven, and realistic. For example, if your weather app says 30% rain, but you see dark clouds outside, Bayes theorem helps update the chance of rain based on both sources. Now move on to third slide, which is beginning the journey of why we choose Bayes theorem. So a team chose to explore Bayes theorem because of its powerful role in shaping how modern systems make decisions. It is not just an academic concept, it is widely used in healthcare, technology, law, and businesses. Bayes theorem represents how real people think. We constantly update our beliefs as we receive new information. Understanding Bayes theorem helps us think more clearly in uncertain situations, avoiding jumping to conclusions, make smarter, more evidence-based decisions. This presentation will explain Bayes theorem in simple terms, show how it works using visual and a medical example, highlight how it is used in real world decision making. So from the next slide, my friend Shrijan will present before you. Thank you.
Good morning, everyone. Today, we are going to explore Bayes' theorem, a concept that might look mathematical on the surface, but its application reach far beyond just number. Bayes' theorem help us to make better decisions in uncertain situations by using new evidence to improve our existing knowledge or belief. Think of it like you believing it might rain today. Then you see a dark cloud. The new evidence updates your belief, and you are now more confident it's going to rain. That's the logic behind Bayes' theorem. So this concept is used in fields like medical diagnosis to detect disease, spam detection to classify emails, machine learning and AI, even in criminal investigation and weather forecasting. So, uh, next slide. Understanding Bayes' theorem, the basics. Let's take a closer look at the formula behind Bayes' theorem. Probability A by B is equal to probability B by A into probability of A by probability of B. Here's what each part means. Probability A by B that updates probability of A after seeing B. This is what we want to find. Probability B by A, the probability of observing B if A is true, and probability of A, the initial or prior probability of A, what we believe before getting a new data, and probability of B, the total probability of B happening. This formula help us to update our belief about an event A based on the occurrence of another event B. It is important to understand the result depends not only on the evidence B but also on how likely we thought A was to begin with. It reflects a balance between our past belief and the new data. So in simple terms, Bayes' theorem is like recalculating the odds after getting a clue. Now the third slide. Visualizing Bayes' theorem. So let's apply Bayes' theorem to a practical example. Suppose there is a disease that affects 1% of people and there is a medical test for it that 99% it's accurate. If a person has a disease, the test will be positive 99% of the time. If a person does not have the disease, the test gives a false positive 5% of the time. Now someone takes the test and it comes back positive. Most people would assume I probably have the disease, but let's see what biopsy tell us. Out of 10,000 people, 100 people actually have the disease. That is 1%. The test correctly identifies 99 of them. But among 9,900 healthy people, 5% of people, which is 495, will get a false positive. So in total, 594 people will be test positive, but only 99 truly have the disease. So the actual probability of having disease even with a positive test is 99 out of 594. That's just around 16%. This example shows how Bayes' theorem helps us to avoid being misled by surface level statistics and instead understand the true likelihood behind events. And this logic applies not just in medicine, but in filtering spam emails, predicting system and failures, or accessing risk in finance. In summary, Bayes' theorem is a powerful tool that helps us to combine prior knowledge with the new evidence to make a smarter data-driven decision. It teaches us how to think probabilistically, a skill that is becoming more important in today's complex data-filled world. Thank you for listening. The next slide will be speaking by Vyom Pandey. Vyom, unmute yourself.
Hello everyone. I'll talk about the real world application of Bayes' theorem. The first one of them is medical diagnosis. Firstly, we have disease prevalence. The In disease prevalence, the Bayes' theorems helps us to find the initial estimate of how common the disease is in the population. For example, we'll get 1% prevalence for some disease that will tell us about more about the disease. The numbers may vary based on the disease and the population. Then, secondly, we have test sensitivity. This translates into likelihood. Uh, it's about the probability a test detects disease when it is truly present. This tells us about the likelihood that a disease is present in the body of the human being tested. This is very reliable and shows a rate more than 95%. Then we have thirdly, test specificity. This indicates the probability that the test correctly identifies the absence of diseases, such as false positive rates. The rate for this is very low, such as 5% and lower. Finally, we have a goal that is to calculate the probability that the person actually has a disease given that they are tested positively. Now, moving on to the next slide. This is how the step-by-step calculation of the Bayes theorem happens in the medical diagnosis example. Firstly, the first step is the probabilities, calculating all the probabilities. Firstly, we have prevalence, as I talked about previously. It has a rate of 1%, then sensitivity at the rate of 95%, and then false positive rates, which is 5%. Secondly, our next step is to apply the Bayes theorem. Now we'll calculate the posterior probability, that is P disease on positive, using the formula. Third step, we have to calculate the total positive probability of the uh, human being actually having the disease, which is when we consider the true positives and false positive, the final probability is 0.059. And then the final step of this process is to find the posterior result. Final probability of disease given positive test is 16.1, as observed in the Bayes theorem. All the examples we have for the Bayes theorem, much lower than intuition might suggest. Next, we moving on to the next slide. Let's interpret the results, what those results mean, and why those results suggest that the Bayes theorem holds such significance. Bayes theorem highlights why a positive test doesn't guarantee disease. Like many times, a patient will be tested positive, but in less than like 5% of the cases, the positive it will be a false positive case, and the patient will not have that disease. The prior prevalence heavily influences actual risk, especially for rare conditions such as chronic illness and many such examples. This understanding prevents misdiagnosis and unnecessary alarms by quantifying how false positives impact outcomes. This, as we mentioned earlier, there is a 16.1% rate that the disease is present in the posterior result. This can help the patients not being alarmed falsely. Now we interpret the test without considering prior possibilities, and if we do that, it can mislead to bad healthcare decisions. Now, Aurangzeb, my teammate Aurangzeb will continue.
Benefits of using Bayes theorem. So, improve decisions under uncertainty. Bayesian methods combine what is already known with new data to reduce uncertainty in predictions and choices. So, there's risk and uncertainty quantification, which helps explicitly measure risks and probabilities, critical in field like finance and engineering. And there are wide applications which is used extensively in AI, machine learning models, medical diagnostics, forensic science, and many other fields. Uh, then we have beyond the formula, embracing Bayesian thinking. So, what is Bayesian thinking? Bayesian thinking is a mindset for smarter decisions. Bayesian theorem is not just a mathematical formula, it's a framework for logical reasoning. It encourages us to stay open to change, continuously refining our beliefs as new data appears. In real life, we face uncertainty every day in health, business, relationships, and other choices. So, think probabilistically rather than in black and white. Be more data driven and less biased by assumptions. Make better decisions by weighing both experience and evidence. In a world flooded with data, adopting this mindset is more essential than ever. Whether you are a student, scientist, or leader, Bayes gives you an edge in understanding and navigating uncertainty. So I'm concluding this with this Bayes theorem for better insights. Bayes theorem elegantly combines prior knowledge with new evidence to update our understanding of the world. This powerful framework helps quantify uncertainty and improve decision making across many disciplines. By adopting Bayesian thinking in everyday life, From medical tests to business decisions, we gain clearer insights and make smarter, more informed choices, unlocking the power of Bayesian analysis to enhance your reasoning and decision making processes. Thank you.